The history of our planet is a violent one. The emergence of everything from a state of nothing into a state of being was surely the result of creation out of sheer violence that we can only assume the case to be. Well, this is still happening out in space, and it's part of the human journey to understand these things as we look out into the vastness. Ancient history only exists on the Earth in the form of civilization. We seldom reference history in the context of space except to acknowledge space exploration by humanity. We thought you guys would like a change of content today, so wait till you hear this. What if there was something out in space that we have been observing from the Earth that appears unable to die? Dubbed the Death Star by many, it takes more than a massive outburst to destroy the mammoth star Eta Carinae, one of the biggest known stars in the Milky Way galaxy. About 170 years ago, Eta Carinae erupted, unleashing almost as much energy as a standard supernova explosion. Yet that powerful blast wasn't enough to obliterate the star, and astronomers have been searching for clues to explain the outburst ever since. Although they cannot travel back to the mid-1800s to witness the actual eruption, they can watch a rebroadcast of part of the event courtesy of some wayward light from the explosion. Rather than heading straight toward Earth, some of the light from the outburst rebounded or echoed off of interstellar dust and is just now arriving at Earth. This effect is called a light echo. The surprise is that new measurements of the 19th century eruption, made by ground-based telescopes, reveal material expanding with record-breaking speeds of up to 20 times faster than astronomers expected. The observed velocities are more like the fastest material ejected by the blast wave in a supernova explosion, rather than the relatively slow and gentle winds expected from massive stars before they die. Based on the new data, researchers suggest that the 1840s eruption may have been triggered by a prolonged stellar brawl among three rowdy sibling stars, which destroyed one star and left the other two in a binary system. This tussle may have accumulated with a violent explosion when Eta Carinae devoured one of its two companions, rocketing more than 10 times the mass of our Sun into space. The ejected mass created gigantic bipolar lobes resembling the dumbbell shape seen in present-day images. What happens when a star behaves like it exploded, but it's still there? The blast unleashed almost as much energy as a standard supernova explosion, yet Eta Carinae survived. An explanation for the eruption has eluded astrophysicists. They can't take a machine back to the mid-1800s to observe the outburst with modern technology. However, astronomers can use nature's own time machine, courtesy of the fact that light travels at a finite speed through space. Rather than heading straight toward Earth, some of the light from the outburst rebounded or echoed off of interstellar dust and is just now arriving at Earth. This effect is called a light echo. The light is behaving like a postcard that got lost in the mail and is only arriving 170 years later. By performing modern astronomical forensics of the delayed light with ground-based telescopes, astronomers uncovered a surprise. The new measurements of the 1840s eruption reveal material expanding with record-breaking speeds up to 20 times faster than astronomers expected. The observed velocities are more like the fastest material ejected by the blast wave in a supernova explosion, rather than relatively slow and gentle winds expected from massive stars before they die. Pretty cool, right? What do you guys think of the information we have chosen to present to you here today? Comments below, and as always, thank you for watching.